We're going to get started, so we're on time. I hope lunch was delicious. So the first talk we have is Dejan Vitlacil from KTH. He has pressed the button. He's going to be talking about the Swedish National Storage Infrastructure for academic research with iRODS.
Thanks. Okay, I'll try to use this one. So I would like first to thank all of the people that were involved in organizing this meeting and making it yet again very nice and pleasant event. So I'll have to write, as Terrell pointed out, through my presentation because my colleague Ilari will step in after 20 minutes and I have quite a lot to say, and I've actually placed quite a lot of text in the slides so you can go through them later also and fetch all of the relevant information. So I'm working at the Stockholm at the Supercomputing Center at the Royal Institute of Technology, and we are also the part of the SNIC, which is the Swedish National Infrastructure for Computing. And in collaboration with our colleagues from the National Supercomputing Center in Linköping, we have been working on the iRODS solution for the national storage. And Swedish National Infrastructure for Computing is a national research infrastructure, and we are tasked to provide large-scale computation and large-scale storage. And our mandate actually says that we need to meet the needs of the researchers from different scientific disciplines coming from higher education institutions and the research institutes. And at the same time, we are supposed to provide these resources through an open procedure in such a way that the best Swedish research is supported and facilitated. And that task actually is up to the Swedish National Allocation Committee, which allocates all of the SNIC resources. So SNIC is, as of now, right now, up to this year, organized as a long-term project funded by the Research Council and has its own board. And the SNIC was formed out of the 6 partners. There are 6 supercomputing centers located in different geographical locations in Sweden, hosted by the universities, technical universities, and they provide to SNIC with the resources, services, expertise, support, and so on. And they are also the local contact points for the user. As this model, by its nature of long-term project, was not really sustainable, in order to give a long-term picture for the research infrastructures asking for the support, SNIC was reorganized starting, or will be reorganized starting for 2018 as a consortium of 10 universities who will govern SNIC in order to achieve this long-term sustainability. And the funds will be coming by 50% from the Swedish Research Council and by 50% from this 10 university consortium. So our main problem in running large-scale storage was that it was not well defined, and our funders, Swedish National Research Council, wanted us to actually stay in the management of the active data. And our problem was that we became a long-term storage because researchers didn't have where to go after they did and treated the data actively in our facilities. So it was not so uncommon to get the publications with a pointer to our services, even if that was not meant to be. But in order to work it out better, we relied on this research data lifecycle, and this picture is coming from JISC. And basically, what is important to say is that we do assist researchers to plan, we can assist researchers to plan and design their research when it comes up to the data. We can help them to collect and capture the data, and especially we are the data generating facility when it comes to HPC. And we offer a large-scale storage for collaboration and analysis. When it comes up to the management, store, and preservation, and sharing and publishing, and then other phases and the other half of this research lifecycle, other stakeholders should take over. Who and how, we will see right now. So the green part is something that we can engage in according to our funders up till now, and not the red ones. And so the problem comes basically who is the responsible for the long-term preservation of the scientific data in Sweden. And the Swedish legal framework has several acts that actually are impacting research data, because it is supposed to be regarded as a public document, because it is stored or was produced at the public authority, and the universities are public authorities in Sweden. So there are a couple of things to keep in mind, and these were very important for us as a guidelines, that the public documents and the research data is not the property of the individual researcher, but of higher educational institution, and where the researcher is employed. And the second is that everyone who wants to access this should be able to do so. So there is some kind of already passive form of open access enabled. And as a third thing, and that's the one we couldn't engage up till now into the long-term preservation, was that the higher educational institutions are responsible for archiving and long-term preservation of the research data, which is produced by the researchers employed by them. And this is, for example, coming from the university at KTH where we work. So these are the references at the universities. So when it comes to the preservation, project diaries, final reports, publication articles, and theses are supposed to be preserved. But when it comes to the raw data that is generated from experiments, interviews, scientific calculations, and in particular pictures, surveys, calculations, statistics, protocols, and so on, it's up to the researcher what should be preserved and what should be sorted out. But even if it is sorted out, it still must be kept for at least 10 years after the financial reporting of the research project. And this is up to the universities. That's why our funders didn't want us as a national infrastructure to engage in the long-term preservation. It's basically financial requirement. So I will describe a little bit of process how we allocate the storage resources within the SNIC, and we do have two different, we have a national storage infrastructure based on two types of services, based on dCache and iRODS, which is going in production by the end of the year. And it usually works like that, a researcher goes to the National Infrastructure for Computing Center and checks for the open calls. And for example, there might be a small and medium allocations open for calls at the Swestore, which is the name for our national storage infrastructure. They would at that point log in into the portal, which is our portal for user and project repository. They would log in, authenticate themselves, generate account or whatever it is requested. They would choose the round, the open round that they intend, where they do intend to apply, and apply, make a proposal. At that point, after the proposal is submitted, it's sent to the Swedish National Allocation Committee, which actually validates and decides whether this proposal is to be approved or not. At that point, if it is approved, the user is informed that the project has been approved. The project is created within the user account is created without the identity management software, and it can choose to authenticate with the grid certificate or the password. And at that point, the temporary password that is sent to the user will enable him with the link to reach our identity management interface, where the user will choose his own password. What is happening at this point in time, as I was mentioning, we have two different services. User will choose the one that is of his choice. And when it comes up to specific up to iRODS, is that we have local, national, and EUDAT iRODS federation. And local is the university's HPC center, where user is actually doing his computation and using, this is one administrative domain, second administrative domain, third administrative domain. So the users can authenticate thanks to the federation locally at the HPC center and then move data to the national iRODS once the computation is over and so on, and or move out to the European HPC center if such need exists. This is EUDAT. You've heard much more about EUDAT from my colleague previously, yesterday, and that there are many HPC centers around Europe and data centers, and this kind of technology that we are using, iRODS, would allow us to move data all around Europe, moving it closer to the PRACE computing facilities or closer to the EGI computing. We do rely on the DAVRODS. Thanks a lot for that. We will probably look a little bit more in enhancement that were placed out. So some of our, we have different types of users. For those who are actually moving small data and need a network mount, we do that for them. We do actually expose also the metalinks from Dell. We find it very useful. As we are also operating this national infrastructure in a distributed manner from the different HPC centers, we do rely on the ticketing system. We generate documentation with Sphinx and GitHub. We do monitor allocation with Munin. We do backups of our core services with the IBM Spectrum Protect and do some monitoring with the usual tools. This is roughly the infrastructure. So these are the 6 centers involved. We have some sensitive data infrastructure. We do have tape and backup infrastructure sitting at 3 different sites in Stockholm, in the Linköping, and in Umeå. They are all connected. They are doing some offsite copies through the TSM functions. And we have HPC resources at the centers, and of course the center storage, which are usually parallel file systems that feed the HPC resources. As the team operating this national service are distributed, we use the Slack for communication, and the team is usually composed of the service coordinator and service team. The service coordinator maintains the contacts with the SNIC, organizes the system upgrades, he is technology expert, he is doing investment planning and other things, while the service team is usually operators on duty, first line support, documentation, and the regular sysadmins work. Due to the requests probably from the universities, this is actually my expectation for the second half of 2017. As we have got more in contact with the universities, we have understand that they need to try to find a process how to deal with larger data sets and how to archive them. And we think that maybe integration between iRODS and Archivematica might be the way to go. So we will probably spend most of the second half of the year trying to figure out first how this is doable, and because at that point the data would be still sitting at the universities, it would just kind of change the responsibility. We move into the hands of the archives and they would process it and use it. Now Ilari will go for the more fun part of this infrastructure. This was just a kind of a rough overview. And then maybe probably we can take some questions regarding this national infrastructure. Kungliga. By the way, Kungliga means royal. So he is the Royal Korhonen at the Royal Institute of Technology.
That's a display. DisplayPort or
DisplayPort, either one.
yeah, either one should work. Should I hope.
So this is live. I mean, you have the microphone here too. Either
Okay,
way.
can you hear me? Because we're having the same DisplayPort problem again. This should work. Try again.
This is a video.
Yeah, but I have the demo.
Something is happening between the video and the recording system.
Okay.
But you have a demo on this machine.
Yes. Or yeah, everything's prepared here.
I have a dongle that goes through here. This may be.
Oh, that
may
might
be
work. Yeah. Yeah. So I'm Ilari Korhonen. I'm working at KTH with Dejan and my colleagues, who some of them other are here with us. And I started there last summer, and after 2 weeks they made me a project leader. They told me that, do you want to be a project leader now or in 2 weeks? And I said 2 weeks. So that was the grace period. And can you hear me? Okay. So we have been at this national project of ours. I have been with them for a year. Yes, I'm just introducing. And we are now going into production this fall. And okay. So as Dejan told you, we have a distributed venture with the National Supercomputing Center in Linköping, and we are running a distributed iRODS together with people at NSC, especially my colleague János Nagy, who is sitting here somewhere, hopefully, yeah, there. And basically we are running a replicated infrastructure so that our core infrastructure, which is of course the iCAT database, resides both in NSC and PDC. And also our identity management server or platform, which is free IPA, is to reside both at NSC and PDC replicated, so that we can fail over from one side to another. And currently the Swestore service that is in production is being operated by quite many of the centers in Sweden, but currently with iRODS we are starting with PDC and NSC. But who knows, later it might involve more Swedish centers as well. So our solution is mostly the usual one, which means Postgres with streaming replication. In our case it's geo-replication, because there is quite a distance between Linköping and Stockholm, which means that we have to use asynchronous replication, otherwise the performance penalty would be too much. So we have to trust that in case of a catastrophic failover event, we can repair the database if there are 1 or 2 transactions missing. But we suspect that that won't happen very often. And
before this solution, Janos also, they tried to implement Postgres bidirectional replication, but this turned out to be not a viable solution for us. So we use the one that's proven to work. So the solution that Janos provided us is a DNS-based failover mechanism where we maintain the pointer to the primary database server in a secondary DNS zone, which will be replicated across NSC and PDC name servers. And we have scripts which invoke the failover to update the DNS records to point to the new primary server and then to promote the Postgres server to a master server and then start the warm standby iCAT on the secondary iCAT server. And then users are pointed to the new login server. And the same goes with storage. With SNIC storage, we use geo-replication as a safety measure against data loss. All data objects in the current Swestore are replicated across any 2 centers in SNIC. And with iRODS, we replicate all data objects with disk pools at NSC and PDC. And for starters, we'll use just a simple one copy in disk at NSC, one copy at some disk resource at PDC, but later we could maybe explore some other options as well, like disk and tape or tape library and tape library. And for the replication, we use the iRODS built-in replication feature, which is by nature synchronous, so that incurs a performance penalty. Because the way that it works is that the first resource server that you are directed to receives the data objects, and then that resource server pushes the replica to the replicating server. So that incurs a penalty for us. We were thinking of maybe exploring asynchronous replication later as some of our other colleagues have, but we'll start with the synchronous because that's the safest way to go. And hopefully the coming upgrade on our network infrastructure could mitigate the issue on replicating. So this is how our current disk pools look like. We are still running our test bed because we are only after summer going to procurement, and we are procuring 1 + 1 petabyte of storage, 1 petabyte to reside in PDC and 1 petabyte to reside at NSC. So currently we have just our development environment. And we have the replication resource and NSC disk pool, PDC disk pool, and we use the random coordination because that provides the best even distribution between child resources without having to revert to the round-robin approach. So we also use tape libraries. We have very large-scale tape libraries both at PDC and NSC. And my colleague Janos, who is a TSM expert, wrote this interface program for iRODS, which enables us to use a TSM native universal mass storage resource. And this work has been published in our GitHub. It's very useful for us, and we suspect that it will be useful for many others, since IBM TSM is quite widely deployed. So this is how our tape resources look like. T01 is the TSM library at Linköping. T02 is the TSM library at PDC. And I will try to demo this, if the internet will allow me. So on the user authentication, as Dejan mentioned, we are using FreeIPA as our identity management backend, and we are authenticating via Kerberos, either server side via PAM KRB5 or using the iRODS KRB authentication module. It's up to the user to decide which mechanism they want to use, and depending on the client as well. Most clients support only password-based authentication, so this enables us to provide this. And we also evaluated the Globus toolkit, the GSI, Grid Security Infrastructure Authentication, but since the Globus toolkit is coming to its end, or its support is apparently coming to its end, we will reevaluate whether we are going to run this in production. And also a contribution for PAM authentication, Janos wrote this alternate PAM interface for iRODS, which has some useful debugging features. And we also plan to investigate further developments on this, because we have an LDAP backend, so we could basically specify a preferred authentication method per user basis. And we could use this plugin to tap into that authentication method per user. Because we also investigated the use of YubiKeys, but we won't be going into production with them yet. There's a cost issue, of course. But this source is also in our GitHub, licensed with a simplified BSD license. Janos published this, so please feel free to take a look. And obviously we had to integrate our identity management into the SNIC services. We have this thing called SUPR, which means SNIC user and project repository, which holds all the approved users and projects in SNIC. And this system manages the approval process. Our colleague working at NSC with Janos, Krishnaveni Chitrapu, wrote our integration module, which basically taps into the SUPR API, and it receives approved proposals for storage projects and users, and it will push these into our identity management and iRODS iCAT. It will create project groups and iRODS users, and they're good to go once they set their password. And for this, we will later on build a proper self-service portal, but for starters, we'll just send a random password to the new users, and then they can reset their actual password. And since we are also running an EUDAT zone at PDC, we of course federate with the EUDAT zone, and we also have a local PDC iRODS zone that we have been developing, which is intended to serve as a landing zone, which seems to be a popular term now, for our HPC users. And we intend to provide a high-speed connection to our local storage resources via the local InfiniBand fabric. And through that, users will be able to stage their data into the national storage resources. And who knows, maybe later some other centers might want to implement something like this, so that there would be center-specific local landing zones which will be federated with the national zone. So we are trying to build a reference implementation for this. And for user interfaces, we recommend native interfaces to iRODS. HPC, 5 minutes. Yeah. HPC users naturally use iCommands in their job scripts, and we also have manuals for CyberDuck, user instructions how to use CyberDuck, and Kanki. And we make the iRODS iCommands available to our HPC users via an environment module in the computing environments. And also we offer a WebDAV gateway, nicely provided to us by the Utrecht guys. We have one gateway at PDC and one at NSC. And also we offer an EMC Metalinks web UI. And we are trying to consolidate all the different kinds of configurations and deployments into our central repository, which we maintain at GitHub. And there is a repository called iRODS Provisioner, which you can download. And this enables you to spin up virtual clusters of iRODS grids. and we use it to test our deployments. And just a final note about this proof of concept of ours, which we have been working lately. We have been building a more high-performance iRODS local solution for PDC. We built a high-performance Postgres database, which we benchmarked at 10,500 transactions per second. And since we have a high-speed InfiniBand fabric of 100 gigabits per second in our compute cluster, we hope to extend that to the iRODS resource servers via IP over InfiniBand. So we have been trying to get some measurements, and we built a test SAN fabric over InfiniBand SRP, and we were able to build from some extra hardware we found lying around in our closets, a file system which can provide about 6,200 megabytes a second read and 5,500 megabytes a second write. And we tried to test how much of this we could push through iRODS. And this was the maximum I was able to get today. It's on average 2,700 megabytes a second and peak performance of 3,300 megabytes a second over 100 gigabits interconnect. Maybe there's more, but this was just preliminary testing. And our test bed looks like this. So we set up a 100 gig fabric, and we also set up an backing InfiniBand storage area network with a bunch of switches we found lying around. Then we found a rack of SUN servers, SUN ZFS optimized storage servers, and we spun up a couple of those, five of those. 8 years old, yeah. And we were able to, with a funny setup that looks like this, we built a fabric, and through this we were testing the throughput. So let's see what kind of environment we'll whip up in production, but this was something we were able to scrape from extra components without procuring anything. Oh, I think my slides are here, so I would just like to acknowledge my work of my colleagues, especially Janos, who is sitting over there. He did a great share of the work in the project, and also Krishnaveni Chitrapu at NSC was in charge of our integrations into the SNIC services. And Dejan is our storage coordinator, and Ilkka, sitting in the front row, is our latest addition. With Ilkka, we built this storage platform, this proof of concept of ours. So, thank you. And